In September 2007, Vinci Construction Grand Projet and Bouygues Travaux Publics, united in the NOVAKA consortium, signed the new safe confinement contract with Chernobyl NPP. The new safe confinement contract involves designing and building an arch-shaped confinement structure. The purpose of this giant confinement arch is to accommodate future dismantling of the object shelter. Top priority has been given to protecting workers, the population and the environment. Measures will be taken to continuously monitor radioactivity and air contamination throughout the construction process. The construction site will be organized around three areas: the object shelter, the erection area, and the waiting area. Work will begin with cleaning and clearing the erection area and dismantling the empty buildings. Excavation in the erection area will be kept to a minimum to avoid generating waste whenever possible. Two wide trenches will be dug to prepare the ground for the future longitudinal beams that will serve as the arch foundations. In the center, solid blocks will support the lifting towers used to erect the structure. Roads will be constructed specifically to serve the erection area. Then civil engineering works will begin, starting with laying the blinding concrete. In parallel, deep foundation work will be started in the trenches. The foundations consist of piling, built using a one-step process where holes are bored and concrete is poured simultaneously. Each pile measures 1 meter in diameter and reaches down to an average depth of 18 meters. The pile reinforcement cage is immersed in the concrete before it begins to set. Drill cuttings are placed on a conveyor that carries them to a facility where they are sorted according to their radioactivity level. In the erection area, the reinforcement is set in place and concrete is cast for the lifting tower foundation blocks. For worker protection, the erection area, covering 90,000 square meters, will be backfilled to an average height of 1 meter using clean filler, and will then be partially covered using concrete slabs. These slabs will form the work surface and provide protection from any radiation coming from the ground. Once preparations have been completed, construction of the first permanent structures can begin, starting with the auxiliary building. This will be the future control center for the dismantling and confinement systems built into the arch. Then it's time to start building the arch itself. The first segments of the arch structure will be pre-assembled outside the erection area and then brought in on a multi-wheel transport vehicle. Each segment weighs an average of 300 tons with a height of about 25 meters. Arch construction will begin with the upper section. The segments will be interconnected with bracing before the cladding is fitted on the center section. The next items to be mounted on the arch will then be brought to the erection area to be connected to this center section using a hinge system. The first lifting operations can then begin, using the towers designed to lift loads weighing over 1,000 tons. The structure will gradually be completed with the rest of its components. Next, the lifting towers will be moved to their ultimate position as the last components, corresponding to the feet of the arch, are brought to the erection area. Once the east side wall has been installed, the pushing equipment will be moved into place to slide the first completed half of the arch to its waiting area, in order to clear the erection area. The second half of the arch will then be assembled according to the same process. All the structural elements will be pre-assembled in a designated area outside the site, where as many components as possible, including electromechanical equipment, cables, ducting, piping and walkways, will be mounted before being brought to the erection area to reduce the number of operations performed within the vicinity of the object shelter. The cladding has been designed to protect the shelter from external hazards and to protect the population and the environment from any radioactive release. A complex ventilation system will also be installed to control the ambient temperature and humidity conditions inside the confinement structure. Once the second half has been completed, the first half will be moved back westwards to connect to the second half, forming the complete arch. The bracing and metal cladding connections will then be completed. The arch will be equipped with overhead cranes, designed for dismantling the shelter and the damaged reactor unit. They will be assembled on the ground, then lifted using cable actuators, secured to the arch structure 85 meters above. After the finishing work and preliminary tests have been completed, actuators will slide the arch 300 meters to its final position. The arch is an oversized structure, 105 meters high and 150 meters long, spanning a distance of 257 meters. Once it has been positioned above the object shelter, the arch and its side walls will be connected to existing structures. The damaged reactor will then be completely isolated from the environment. Designed and built by NOVAKA, the arch will be used in a later phase to dismantle the shelter under the safest and most flexible conditions possible, keeping human intervention to the strict minimum.